Crush it like I'm killing this. Everybody feeling this. Fired up math time. Spitting out those mad rhymes. Crush it like I'm killing this. Everybody feeling this. Fired up math time. Spitting out those mad rhymes. Triangle mid-segments. They're the best thing in the world. Yeah, I went straight from rap to I don't know what that was. So we're talking about mid-segments today. A mid-segment is a segment that joins midpoints of two different sides. So in this blue triangle right here, triangle ABC, you can see these hash marks indicate that this point in between splits this line in half, so that is a midpoint. Same thing over here. These two hash marks show that these pieces are equal, which means this is a midpoint at point E. So the line connecting those two midpoints is called a mid-segment. Some cool things about mid-segments, okay? Just some properties about mid-segments on a triangle. Mid-segment is always parallel to the third side. You can see right here this little arrow. This little arrow means that these two lines are parallel. So our mid-segment is parallel with the third side. And also, another cool thing is the mid-segment is always half the length of the third side. So whatever the length of this is, the third side is going to be twice as much as the length of that mid-segment right there, which is kind of a cool property about mid-segments and triangles. Alright, so right here, let's do a little math with them. Given that L is the midpoint of DC and M is the midpoint of DE, find the length of LM. Alright, so right here you can see right here's our mid-segment from L to M, and that's what we want to find. We see our third side is 20, so we know our mid-segment must be half of the third side, so it's 10. And yes, it is definitely that easy. On this one anyways. So on this one, our mid-segment we know is 11, so it wants to find VT. Well, VT is our third side. Well, we know the third side has to be twice as much as the mid-segment. So, twice as much as 11, that's 22. All right. So now, get a little bit tougher. Let's do something with algebraic problems. All right, so now we see this is our mid-segment because it's connecting the midpoint here, the midpoint here. So two of these should equal this. All right, so you can set this up a couple different ways. One way is you can say 2 and then in parentheses 3x minus 6. So 2 of these should equal my third side down here, 4x. That's one way to do it. Or you could do kind of the opposite and say half of 4x should equal 3x minus 6. And either one should give you the same answer. So let's just do this real quick. Do our surety property. 2 times 3x is 6x. 2 times 6 is 12. And then we're going to subtract 6x from both sides. Negative 12 equals 4x minus 6x negative 2x. Then we divide by negative 2. Divide by negative 2. Divide by negative 2. So x equals 6. Alright. So we get the x is 6. And then over here, a half times 4 is 2. So we got 2x equals 3x minus 6. Minus our 3x and minus 3x. 2x minus 3x is negative x. And over here we have negative 6. Divide by negative 1. So x equals 6. So either way you should get 6. But that's not the end of the problem. The problem says solve for x and DC and KM. So we've got x, but now we've got to figure out, well, what are DC and KM? So let's figure out KM real quick. KM is 4x, but now we know x is 6. So 4 times 6 is 24. Alright. And a smart way to do this next problem to find CD would be say, well, remember our mid-segment is half of this. Well, if that's 24, half of 24 is 12. Alright, so we can just plug in, or we don't have to plug in, we can just know it's half. If you do plug 6 in right here for x and do 3 times 6 minus 6, you will still get 12. So there are our other two answers for this problem. Alright, so now a little bit more complicated thing here. So if we do mid-segments on a coordinate plane, we want to prove the mid-segment theorem. Alright, so this is one of those things that's going to have a few steps to it that can take a while. So first step is to simply plot the points that we're given. Second is to find the midpoint of two sides. So we got to remember our midpoint theorem that we did in Module 1. Alright, we're going to use that again. And then we're going to construct the mid-segment once we know the two midpoints. Just connect the midpoints to make the mid-segment. Alright, and then the fourth part, we've got to find the slope of the mid-segment and the third side. Alright, so that is something that we practice also in Module 1, but it's been a little while, so finding the slope. And last, we've got to find the distance of mid-segment and the third side. So you might remember, to find the distance, you've got to do the distance formula. Or you can use Pythagorean theorem whenever you're looking at a coordinate point. So I'm going to go back here and write down some of these formulas you're going to use so you can have them for your notes. Alright, so our midpoint formula is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So you just add up your x's and divide by 2, add up the y's and divide by 2. You might want to use the slope formula to find slope, y2 minus y1 over x2 minus x1. And that one can help you find the slope. And then in order to find the distance, you can use either the Pythagorean theorem, a squared plus b squared equals c squared, or the distance formula, which is x2 minus x1 squared. That looks like a y to make it a little more xy, plus y2 minus y1 squared. So these are the formulas that you're going to need whenever you're doing these steps on this next problem. So let's go a step at a time through one of these. So here's our points and our coordinate plane we're gonna do. So first step is to plot the points. I want to pause it. You guys go ahead and plot the points real quick on your graph. All right. So we got our points plotted, A, B, and C. So now the second step is to find the midpoint between CA and CB. Really should be find the midpoint of CA and CB. So right here, we want to find the midpoint of CA. We use the points A and C in our midpoint formula. So our midpoint formula tells us to add the x's. So we're going to have 0 plus negative 4. And then we divide by 2. And we're going to have our y's added together. 6 plus negative 2 divided by 2. So 0 plus negative 4 is negative 4. And negative 4 divided by 2 is negative 2. And 6 plus negative 2 is 4, and 4 divided by 2 is 2. So our midpoint for AC should be at the point negative 2, 2. So we go over negative 2 and up 2, and right there you can see is our midpoint. I'm going to do the same thing for AB. So this time we're going to use the point A and the point B to find the midpoint. But do the same thing. We're going to add the x's, 0 plus 4 divided by 2. And 6 plus negative 2 divided by 2. Let's make this 4 a little more 4-ish. Oh, that didn't help much, did it? Alright, you get the idea. So 0 plus 4 is 4, divided by 2 is 2. 6 plus negative 2 is again 4, divided by 2 is 2. So this midpoint is going to be at the point 2, 2. Right in there. Alright, now the next step is to construct the mid-segment. Well, that's simple. We just got to draw a line that connects the two midpoints. So right there would be our mid-segment. So I can make it a little bit bigger for us. Okay, so that's our mid-segment because it connects the midpoints of the two sides. Now the next part says we need to show that DE is parallel, this means parallel, to BC. So in order to show they're parallel, we need to show that they have the same slope. Remember, parallel lines have the same slope. Well, when we're looking at it, we can see this is a flat line, so its slope is 0. It has no slope. And this is also a flat line that has no slope. So we could just say for our part to show that DE is parallel, we could say DE has slope of 0. BC has slope of 0. So they are parallel. Okay? Anytime they have the same slope, they're parallel. All right, now the last step is to show that DE is a half of BC. So we want to show that part that we know that the mid segment is going to be half of the third side. Well, right here it's real simple because the mid segment and the third side are lying along the lines of the graph, so we can just count. So this is 1, 2, 3, 4. Right. And then CB is 1, 2, 3, 4, 5, 6, 7, 8. Right. And we'll go and call this DE the points, the midpoints. Okay. So DE is 4 and BC is 8. So we can see that 4 is half of 8. All right. So for our fifth part, we can just write something to that effect. DE equals 4 and BC equals 8. And you could say, 8 is half of 4. Alright. Cool. So now let's do another one that's might be a little bit more difficult. So we're going to do the same thing. First step is to plot our points. Let's do this one in blue. So plot point 4, 6, which is right here. It's not blue. Here's blue. 4, 6, 6, 0, and 0, 0. Alright, so we're going to draw some lines here as close as I can get to being right without being too curvy. Whoa, that's ugly. I got an idea. Let's do this up here. Let's get the line. There we go. How you like me now? Eh? How you like me now? That's what I'm talking about. That's a lot better, isn't it? Okay, so there's my triangle. Alright, now the second step. Okay, remember that second step, find the midpoint between CA and CB. Now this problem though, so we're going to find the midpoints between CA and CB. So C and A, using the midpoint formula, going to add the x's, 4 plus 0 divided by 2, and 6 plus 0 divided by 2. 4 plus 0 is 4, divided by 2 is 2, 6 plus 0 is 6, divided by 2 is 3. So that midpoint's 2, 3. And then also C and B. So we got B and C. So add the x's, 6 plus 0 divided by 2, 0 plus 0 divided by 2. Well, 6 plus 0 is 6, divided by 2 is 3, 0 plus 0 is 0, 0 divided by anything is 0. So our midpoints are 2, 3, and 3, 0. So go over 2, up 3, and over 3 and up 0. So right there are our two midpoints. So this would be our mid-segment this time. So this time it's not going to be as easy just because our mid-segment and our third side don't lie right on the grid lines. So we're going to actually have to do a little bit of slope calculation and stuff like that, but that's okay. We're smart, we can handle it. So next step, third step is to construct the mid-segment. We already did that. And then show DE is parallel to AB. So we got to figure out their slopes. So this was point C. Right here we had point B. And up here was A. So we'll call this D and E. So we need to prove this is parallel to that. So what's the slope of this? Well, let's just count rise over run. We go down 3 and over 1. So our rise is -3, our run is 1. So the slope is -3 over 1, which is -3. What's the slope from A to B? We go down 1, 2, 3, 4, 5, 6. So our rise is -6, and we run 1, 2. Our run is 2. So our slope there is -6 over 2, which is also -3. So both of our slopes are negative 3. So you can just explain both slopes are negative 3, so they are parallel. Alright, and then last step is to show that DE equals half of AB. So in order to do that, we need to know their distances. We need to know how far they are from DE and from A to B. So we can use distance formula, or you can use Pythagorean theorem. So I'm just going to use Pythagorean theorem since I already know two sides of this triangle. So I got my A, I got my B, I just need to find C. So we say, alright, well we got 1 squared plus negative 3 squared equals C squared. And that'll tell us the length of our midsegment. 1 squared is 1, negative 3 squared is 9. So that's 10. Then you take the square root. So C equals the square root of 10. Do the same thing for AB. So we've got 2 squared plus negative 6 squared equals C squared. 2 squared is 4. Negative 6 squared is 36. So we get 40 equals C squared. Take the square root to get C by itself, and we get the square root of 40. Now when you type this in the calculator, you should get something like 6.4, I think, 6.4, something like that. And type in this, and it should be like 3.1, maybe it's 6.2. Yeah, I think that's actually 6.2. So this is going to be 6.2, and this is 3.1. Alright, so remember the whole point is for the third side to be twice as long as our midsegment, which it looks like it is. So we can say for this one that DE equals 3.1, AB equals 6.2, so DE equals half of AB. Alright, so time to practice. Thanks for your attention. Go do some math now.